So friends, welcome to this second tutorial on computer networks. In the last tutorial, we looked at these points. We looked at what is CN, then what is LAN and internet, and we also looked at the various applications of computer networks. Now, in this video, I am going to explain you the design issues or the challenges that come in the design of computer networks. So, you can also call these as challenges. So, to start with, I gave this example earlier in first tutorial also, that we have a LAN and LAN is connected to gateway is in turn connected to internet. And I said that there are many applications of internet like surfing websites, sending and receiving emails, video conferencing. In LAN you can share resources like printers and folders. Whatever be the application, the main thing is message transfer. Right? Everything is based on message transfer. So when you are sending an email, a message or a packet goes out of your machine. When you surf website, packets are coming in or coming out of your machine. So, now, keeping this in mind, message transfer, or we can also call it packet transfer. What are the challenges? The first challenge, as mentioned here, is addressing this one. Suppose you are writing a letter to your friend. You must know your friend's address. Then only the postal service can deliver your letter to your friend. And we all know that we put letter in an envelope, and then in the envelope we write from address as well as to address. These are the two things we write. And the to address helps the postal service to deliver your envelope to your friend's home. Similarly, when a packet or a message is transferred, the packet should have address of source machine and the address of destination machine. So some method of addressing the machines is required. Here I have given symbolic names A, B, C, D, but this is not the way internet or network works. In internet, there are three types of addressing schemes used. One of them, which is well known, is IP addressing. The other is known as MAC addressing. MAC stands for Medium Access Control. And the third address is known as port numbers. Three kinds of addresses are there in networking literature. We will talk about all three in subsequent videos. But the thing to remember is that for the message or for the packet to get delivered, The important thing is that it should have from and to address, right? And that is why every machine which is connected to internet, which wants to communicate with other machines, should have some address. And as I said, that in internet, three types of addressing mechanisms are there: IP, MAC, and port numbers. Okay. So this is one challenge or one issue. Now, let us look at the other issues. The second one in the list is path finding, right? So going back to previous slide, you can see that suppose this machine A is source and this web server is destination. So from this source A, we want to send a message to this web server. Now, as I explained in first tutorial, I said that from A, message will go to switch, from switch it will go to gateway, and then when the message or the packet, when it enters the internet, some path should be available, right? Suppose there are 4 routers, 1, 2, 3 and 4. The packet first goes to R1. Now router 1 has to decide that the packet has to reach this destination. Where should it forward the packet? Right? And this work should be carried out by every router. So in this example, suppose router 1 knows that the web server can be reached through this path, then router 1 will forward the incoming packet to router 2, router 2 will forward it to router 3 and 3 will forward it to web server. But this is possible only if every router has knowledge about how to forward a packet to web server. It may happen that these yellow lines, they indicate the client networks. C1 is one client network, C2 is other, C3 is third. Let us assume that some client is connected to router 4 and they give router 4 a packet for web server. Router 4 will take this path. But this is possible only if routers know the path to the possible destinations. Without knowledge of path, data communication is not possible. So path finding is also an issue which is to be handled by internet. So in our future study, we will look at how routers find path to various destinations and how do they process incoming packets. And you must agree that from one source to a destination there can be multiple paths, but we always prefer shortest path. So similarly, in internet also, from one source machine to other destination machine, there can be multiple routes, multiple paths, but routers always forward your packet so that the packet reaches the destination in the smallest time or through shortest path. So path, first issue was addressing, second issue was path finding. The third issue is packet is corrupted. Let us say the packet is originated from source A and it passes through this path and reaches the web server. But in its journey through internet, due to the noise present in the communication medium, the packet is corrupted. The meaning of corrupted means that bit 1 changes to 0 or 0 changes to 1, right? Suppose your packet, it contains this is your packet, right? In practice the packet is of larger size, but we say that this bit pattern is our packet. If packet is corrupted, it may happen that the sender transmits this packet, but when it reaches the receiver, it becomes like this. So as you can see here, first two bits were 1 0, but they have reached as 0 1. So corruption means that one or more bits are flipped. Now the question is that how the receiver would know that whatever it has received, it is indeed the same thing that sender had sent, right? So receiver has to detect errors. When a packet comes to a machine, it should first check that is this the same thing that sender has sent? Now there are certain methods to verify the integrity of the packet. Suppose errors are detected, then the machine should try to correct those errors. So detect and correct the errors. So the challenge or the issue is that how do we detect errors and how do we correct the errors? There are methods, protocols available. Now the next challenge is loss of packets. Often in internet, many times the routers are congested. Many times this problem occurs. Now what do I mean by congestion? You can see in this diagram that a router is not connected to a single client network. It may be connected to multiple client networks, or in other words, a router is receiving large number of packets. And the incoming packets are stored in buffers at routers. Buffers means RAM, memory. Now if the clients are transmitting a large number of packets, it may happen that the buffers at the router are full and the new packets cannot be accepted by the router, and so the newly arriving packets are lost. And as they are lost, they are not forwarded and they do not reach the destination. Let us say in our example, assume that this router R2, suppose it is congested. What will happen? The packet will reach till router 2, but then as there is no space at router 2, that packet will be lost and it will never reach the destination, that is workstation. And the sender or the source will never get a reply. So summarizing, congestion or traffic has resulted in loss of packets. The challenge is that how do we detect packet loss and how do we recover from loss of packets? There are also algorithms which detect and correct congestion. As I said that due to congestion, packet loss has occurred. And so we also need to look at, or we also need to detect if internet is congested or not congested. If internet is congested, then measures should be taken to get rid of congestion. So once we get rid of congestion, we will be able to prevent future packet loss. Now comes the next issue, that is sender is too fast. Let us take an example that source A is transmitting packets to destination WS. Internet is not congested, routers are free, and source is transmitting packets at a very high speed to this destination. This destination may be receiving packets from many other sources. And if all of them transmit to this destination at a very fast speed, this destination soon will be overloaded. In other words, the buffers present in this destination will be full, and so no more packets can be accepted. So in that case, if sender sends a packet to this destination, the packet may reach the destination, but the packet may not be stored there. Packet may not be accepted. Why? Because there is no space, memory available at the destination to accept the packet. What is the cause? The cause is this: the sender is too fast. So there should be some mechanisms to tell the sender that please slow down. A fast sender will not only create problems for receiver, but it will also create congestion in internet. Please understand that the objective of this video is to convey that there are some challenges or there are some issues in the network design. So I am not going to talk about details of all the issues, because studying computer networks is nothing. It is about understanding these issues in detail and then studying their solutions. So the entire syllabus is revolving around, or it is evolving around, these issues. And the thing that I want to tell at this point is that this list is not complete. There are other issues as well. But as I said, I want to convey that there are challenges. So I have mentioned some important issues, and in the due course of time, we are going to study the solutions of these issues, and we may look at other issues. Coming back, the next issue is heterogeneity. What do I mean by heterogeneity? You know that internet or large number of computers are connected to internet. These computers, all the computers may not be alike. What I mean is that they have different architectures. They may have different operating systems installed. This is what I mean by heterogeneity. Computers of different architectures, computers having different operating systems, they are connected to internet and still they are able to communicate. For example, this source machine may be running Windows operating system and the web server is running Linux operating system. So that way they are heterogeneous, but still they are able to communicate. Even in real life, when you surf websites, you don't know whether the website is installed or hosted on a Linux machine or on a Windows machine. The point is that heterogeneous machines should be able to communicate without any disruption. Then comes the security part. Many times when sender sends a message, for example, source A is sending a message to web server, it wants that no one else in the path. Here there is a switch, gateway, router R1, router R2, router R3. These 5 things are on the path to web server. So no one else except this machine should be able to interpret the message. So secrecy is sometimes required. And these days, when we do monetary transactions on internet, secrecy or security has become very important. So how to provide secrecy of messages is also an issue. Security itself is a separate domain and secrecy is just one aspect. There are other aspects like authentication, authorization. But as I said, my aim is not go into deep at this point. I have just mentioned about secrecy. So there are various protocols or methods which help us to achieve secrecy of message. Next one is process to process communication or process to process delivery. Again, coming back to this example, let us say that on machine A there is a web browser running, and in the first tutorial also I had mentioned this. On the web server machine, a web server program is running or web server process is running, and it is the web browser using which you are typing http www.abc.com. So this web server is for a website abc.com, and the web server process is sending you the web page of abc.com. So using routers, your request message may reach web server machine, but how the operating system of web server machine would know that the message is for web server process only? As you know that on a machine some operating system is there, but above that operating system a large number of programs or applications or processes are running, say n processes are running. So when a message comes to operating system from internet, how would the operating system know that out of these n processes who is the correct destination for the process, for this message? Using pathfinding, routers deliver the message to a correct destination machine, but on that destination machine, which application or which process should be given that message, that is known as process to process delivery. Lastly, group communication. These days, most of the students have studied through online mode, where a teacher is sitting at his place and he is delivering his lecture. And his lecture is being received by a group of students. So this is one of the best examples of group communication, where there is a group of people communicating with each other. If you have observed till now, in my example, there was a single source S, A, and single destination WS. But group communication or video conferencing is also an important application of internet. So how to support group communication, how to implement it, is also an issue or a challenge. It is not same as unicasting. Unicasting means one source, one destination. This is multicasting, one source and many destinations. Multicasting or group communication is to be dealt with differently than unicast communication. Now, as I said earlier, that study of computer networks is to understand the design issues and their solutions. So I hope that you got an idea about what are the challenges in data communication. Now, one important point is that our focus in this video series is wired networks. We assume that computers, routers are connected through wires. The question will come that then what is wireless networks? Here is an example of wireless LAN. You can see in this diagram that there is an access point, and you must have seen access points in your lab or in your office where Wi-Fi facility is available. Normally, the access points are devices which are mounted on wall, and these are the laptops L1, L2, L10. These laptops are connected to access point using wireless links. These dash lines, white colored dash lines, they mean wireless links. So whenever you turn on Wi-Fi in laptop L1, you get connected to an access point. So whatever packets come out of your laptop, they go to the access point, and from access point they go to switch, and from switch they go to gateway and then to internet. So this portion is known to you. Only thing is that now our network switch, which was connected to PC1 and PC2 using wires, it is connected with access point using wire, but access point in turn is connected through two laptops using wireless medium. So I have drawn a yellow color boundary. So this portion is known as wireless LAN. And it is often very easy to set up wireless LAN because there is no need of wires. Only thing is you put up an access point, connect it to switch, and then laptops and mobile phones can connect to access point wirelessly. So it is easy to set up, it is less costly compared to wired LAN, But the main disadvantage of wireless LAN is its data rate. These days, wired LANs provide data rate up to 1 Gbps, 1 gigabits per second, but wireless LAN, they does not provide data rate in the order of Gbps, they provide data rate in the order of few Mbps, megabits per second. Keep in mind that in internet also the links between routers may be wireless. But as I said, in this tutorial series, our focus is on wired networks. The reason of telling you is that the protocol design or the challenges are different from wired network to wireless network. The protocols which are designed for wired network, they may not be useful for wireless networks. Some modification is required, and that is why we should keep in mind that our focus is on wired networks. So I think that this is enough for this video. In the next video, we will talk about layered architecture. In other words, we will try to arrange these challenges in the form of layers, and we will look at the network in a more systematic manner. So with this I stop. I thank you for watching my video. Thank you very much.